Hello everyone, my name is Flaubert and today I'm going to talk about titanium and a little bit of the applications. Titanium is a chemical element with symbol Ti, the atomic number is 22, and the atomic weight of titanium is 47.88. It is a silvery gray metal of group 4 of the periodic table, and titanium is actually the ninth most abundant element on Earth. And there are like different four grades of titanium alloys. Titanium by itself is not found freely in nature, but it is found in a few minerals such as igneous rocks, and then titanium oxide, iron titanium oxide, titanite, perovskite, and other minerals. And is most commonly found and mined in Australia, Sierra Leone, South Africa, Japan, Russia, and even the moon. So the titanium is extracted using the Kroll process, which is a magnesium reduction. So the oxide is converted to chloride through carbohydrogenation. Then it's condensed and purified by fraction distillation, and then reduced with molten magnesium in argon atmosphere. And then we get the sponge, and from the sponge, we can make the titanium alloys. Titanium is a low toxicity level metal, and it is biologically compatible with human tissues and bones. But when in a metallic form, it can be a fire hazard, and when heated, it could be an explosion hazard as well. But no environmental effects have been reported at all. And titanium is 100% recyclable equal metal. Some of the titanium properties that it's pretty low density. The melting point high is 1933. The boiling point is 3560 Kelvin. And the appearance is shiny, dark gray metal. And the atomic rate is 147. It is a good corrosion resistance metal, so it will take a lot to like get corroded. It is a high strength metal, and the strength to weight ratio is pretty good, and it's a very good resistor. The titanium properties allows it to have so many applications on our daily lives, such as golf clubs, tennis rackets, knives, jewelry. Also, in the medical field, maybe surgical tools or implants. And then also in the military field, aircrafts and naval ships, missiles, spacecraft, and automobile racing. And also, we can use the titanium as like pigments, additives, or coatings for painting. And now I want to get into the most commonly used titanium alloy, which is the Ti6Al4V. And it's typically used for medical devices or implants. And then you can see right here the aerospace application. And then as far as implant goes, like it can be a knee implant, a hip implant, or elbow, shoulder sockets, even like maybe a tooth root canal. So there are a lot of applications as well in the medical field because titanium is so biocompatible to our human body. For anyone that was curious, I just wanted to put this slide out there. It is a slide that has like a few properties that help us make the material selections before doing any project. And once again, I wanted to emphasize the density to strength ratio. And so the titanium structure-wise, it is a HCP in the alpha phase when it's stable at low temperatures, but it is a BCC at the beta phase stable at high temperatures. So you get a little bit of the two different structures in there. These are my HCP and BCC and 3D models that I designed using ThinkCAD. And they're just crazy how to think particle shape like this and in the 3D model make up the titanium sponge. It usually looks like this before they crush it up and during the curl process. So for this last slide, I wanted to conclude by touching up on some points that might help you maybe in the future whenever you work in the industry. and decide if you want to use titanium or not use titanium for your project. So I'm gonna talk about a little bit of the advantages and disadvantages of using titanium, and then you can use your judgment to see what's best for your project. Titanium has high corrosion resistance, mainly because of a continuous and consistent layer of oxide that forms spontaneously when exposed to oxygen, and it helps prevent and just like prevent the harshness of the seawater and makes an ideal choice for underwater and marine applications like submarines and I don't know, maybe offshore oil and gas operations and anything to do like under the seawater. It has a high tensile strength and lightweight to low density ratio, so especially the military, really benefits from that, military and aviation, and just aerospace industry in general. Because when you're flying, I don't know, aircraft, you want it to be as light as possible, but also have the strength to like withhold all the turbines and all the, I don't know, the pressure changes and everything that goes on ever even like the gravity force. So it's a good materials like resistance and make sure that it doesn't break down whenever the pilots are flying. It is also heat treatable and easily to like manipulate, the water ability. So even though it can resist to extremely high temperatures, we can also easily weld and fabricate whatever parts we need. So that's perfect for the automotive industry. I'd say like engines and maybe gearboxes and pieces like that of a car like can really be made of out of titanium. Addict. So even though maybe you did a procedure before, maybe a hip replacement, if anything else happens and you need another MRI or X-ray, you're totally safe because titanium is not magnetic at all, and you'll be fine to do those images and just the diagnosis protocol. One of the few disadvantages is that it has poor shear strength, so it has poor shear strength and surface wear properties because it tends to slip or seize when in contact with sliding parts. So in order to overcome this, oxidizing or like nitriding treatments like can be used to make sure that the shear strength is pretty acceptable. And finally, the last disadvantage is that titanium is corrosive to strong acids. So it might not be corrosive to salt water, but for example, sulfuric acid can really like corrode and make a damage on it. So to solve that problem, can add an extra protective oxide layer on the alloy. So that way it won't be as corrosive. And that's all I have. Thank you guys for listening.